Swayam Prabha. Digital India. Educated India.
Welcome back. I am Abhinav Dhal, and we are going to discuss the third part of automatic facial expression recognition, which is in the series of the Affective Computing course. So friends, we have been talking about the different techniques in facial expression recognition from the perspective of static versus dynamic facial expressions, posed versus spontaneous facial expressions, the different features which we extract, and the different data sets which have been proposed in the affective computing community. Now we are going to discuss about a newer dimension in automatic facial expression recognition. So if you notice on the slide here, so what we have here is a frame from the extended Cohen-Kanade Plus dataset. As you notice here, there is one subject. The subject is looking directly into the camera, and there is a posed expression. Okay, so this is a posed expression. Now, we discussed earlier that we would have spontaneous expressions in the world as well, right? That's how we communicate through nonverbal communication. What we have also seen is, given that there is so much data which is now available on social media, and also that there are these circumstances where we are not alone, we have a group of people around us. So in that case, there can be scenarios like this, where you have a group of people and a camera is recording either an image or a series of images, a video. And what we want to understand is that what is the overall perceived emotion of this group, right? Why do we want to do this? Well, of course, I've told you one reason already. There is abundant amount of data available. And then we also see that in tasks such as understanding the cohesion of a group, that is an indicator of, let's say, the unity within a group. The task where we want to understand how a group of people are performing. So in that particular case, the facial expressions along with other cues gives us a vital cue. Now, as compared to traditional facial expression recognition where we have one subject, in this case, there are a large number of factors which will affect the perception of a person when they look at, let's say, a photograph of a group of people. Now, we would like to map these factors onto a computational model so that we can do overall facial expression recognition for a group. Now, the question, of course, is how can we represent the emotion of a group, right? So, in this, similar to how we did for single subject based facial expression recognition, we can use the universal category. So, that is your angry, sad, disgust, happy, neutral, and so forth. You can also use here the valence and arousal continuous emotions, right? So, we have seen in the earlier lectures, we can use this valence and arousal to indicate the emotion and its strength, positive or negative. Now, if you have a video of a group of people, you can then indicate that what is the primary emotion and then what is the intensity, right? Now, we will go through this part trying to understand first what is going to be the contributing factor when someone looks at a photograph. Why will they say, for example, a group of people look happy, or they are in a professional setting, so maybe they are showing a neutral expression. So, we did a survey, okay. Now, this is one of our earlier works where we asked users a question where we said, well, you have two images. Can you compare these two images and tell us that which group of people is happier? Now, once you have chosen the choice, there are a set of questions which are derived from works in psychology, which have already studied how humans are perceiving the groups and what is their choice based on these factors, right? For example, you could say you chose image A having better higher happiness as compared to B? Is it that because the faces are less occluded, or the faces in a particular group have larger size, or maybe some people have particular attributes which are affecting your judgment? Based on that, we did some analysis and we found out, for example, there are a set of contributing factors. The example is larger faces, more smiling faces, they are getting more weightage. So, in a way, when you look at a group of people, and let's say this is a large group of people, you don't need to look at each and every face in order to tell me what is the overall group emotion, right? You can look at a few people and that can give you, a correct understanding of the perceived emotion. Now, we also asked our participants that what are the reasons which, other than the ones asked based on face size and others, which made you choose a particular image. So, if you notice, they say there is more togetherness in this group. So, I am rating the happiness of this group higher than the other one. There is a more colorful scene in the image. So, that will mean perhaps the event in which these people are, that is more positive. Now, moving forward in this, we group these factors which are affecting the perception of a group of people into a top-down affect and bottom-up affect. Now, friends, what is top-down affect? Top-down affect is, here you have a group of people and they are at a particular place, let's say they are at a park. Then what is the effect of the neighborhood of each person on another person? For example, for this subject, what is the effect on his or her expression based on with whom they are standing and where they are standing in the group? So, typically the structure of a group also tells you about the social setting of that group. For example, if you are in a formal setting in an office, then it's possible that the senior person could be in the center of the group. If you are with friends, maybe this condition will not hold. The other is the scene. What are the things which are in the background, right? Maybe if there are balloons, it can indicate it is actually some celebration going on. Or if it is actually some chairs and people are wearing robes, then maybe a convocation is going on, right? So, the clothes of the people and their body pose. Now, the second category is the bottom-up affect. This is essentially saying what is the individual expression and what is that contribution of this individual's expression towards the overall group emotion. Then there are things such as attractiveness, the spontaneous expression, age, gender, large faces, center faces, clearer faces and so forth. So, here we are looking at each person at a time from a computer's perspective. Now, this is also somewhat in sync with Barr's scene context model, which proposed that when we look at a particular scene, we would do a very low resolution quick scan of that scene. So, it gives us the holistic picture of what you have in front of you. Once we have done that, we will pinpoint a region of interest and we will fixate on that. What that means is, you are looking, let's say, at a scenery. Now, you will do a quick scan, look at the low resolution version of the scenery and then maybe fixate on the house which is there just beside the mountain, because that is what is of interest to you. So, in that way, first you are looking at the overall group, then you are looking at the individual people. Okay. Now, there are several ways in which one could model these attributes into a facial expression recognition system. We are going to discuss one such model. So, let's say we have an input image. In this image, we have 6 subjects. Now, what we can say is, we are interested in the top-down representation, those effects, and the bottom-up, right? For me to, let's say, first look at top-down, I need to have a method of modeling the group. So, typical pipeline which we have discussed till now for facial expression recognition, friends, we use an object detector. right? In this case, when you will use the object detector for detecting the faces, it will give you 6 faces in this image. Now, once you have it, what you could say is, well, let my group of people in image be a fully connected graph. Okay. So, you have a fully connected graph here. In this fully connected graph, your vertices V are the faces and the edges are representing the link between two people. For example, in this image F1 and F2 are linked, so this is an edge. The weight of an edge is essentially, let us say, the distance between two faces. Now, the distance between these two faces can be calculated based on the face location. So, you can take the center of the two faces and let us say calculate the Euclidean distance. So, now let us say the Euclidean distance between these two faces will be the weight of the edge between these two vertices, two faces. Now, top down was based on where are people standing, with whom they are standing, and then what is the effect of their relative location onto the neighbor, onto themselves, which is affecting their expression, and that of course in the end is giving the impression of the overall group's perceived emotion. So, what we do is, after we have a fully connected graph, we say, well, let us compute a min span tree. Okay. So, for example, you can use the Prim's min span computation algorithm, and that is going to tell you who is the neighbor of whom, right. So, you have a fully connected graph, you computed a min span tree, and now it actually gives you the shortest path. And in the classic sense of this group as a fully connected graph, it is telling me now what is the shortest path. So, in a way it could give you, for example, if F1 was your first phase, then F1 is, let us say, linked to F2, it is F3, then F4, from F4 you can reach maybe to F5, and then you can reach to F6, just as an example. Now, what that means is, with this min span tree, F2's two neighbors are now clear to me. So, F2 has two immediate neighbors, right. So, I can now calculate more information about the relative location, right. Just as an example, what I can do is, I can say, well, the relative face size of a person with respect to his or her neighbor is a rough indication of where that person could be standing in a group, right. If that is the case, I can do something like this. I can say, well, if theta of I is the relative face size of the ith subject in my group, then that can be calculated as the face size, which I can get from the phase detection which I have done. So, let us say that is S of I divided by the average of the size of the neighborhood. Okay. So, I can get this from F1, F2 and F3, and this simply is a very rough indication of where people are. Similarly, I can compute the distance of a particular person, let us say F1, from, let us say, the centroid of the group. Earlier I gave an example, right. When you are in a formal setting, generally seniors are in the middle of the image. Same goes for family photographs as well. You may have noticed, the grandfather, grandmother, they would be sitting in the center, the elder ones would be on the sides, children could be in the lap, right, and so forth. So, one's distance from the centroid can indicate how much is their weightage in that social setting. In vision, computer vision, it is also referred to as, finding a very important person. So, you have a group of people, who is the important person in this image? Once you know that, that gives you a fair bit of idea about the social setting of that group, where they are, what they could be doing, and what could be the perceived emotion, right. So, if that is the case, I can do it this way. I can say the distance is actually based on the centroid of the group, and then you can subtract it by the location which you get for the face. So let's say the location is L for a group I, and this is group, so you can compute this. Okay. So larger the distance, you can then penalize the expression. Now similarly, friends, you can look at the bottom effect, right? I'll give you an example. You can do AFER, so that is your automatic facial expression recognition, and you can compute a particular face, let's say happiness, right? So H of I will tell you how much happy a particular face is, right? Now you have this information, you can use D of I and theta I as weights and apply it to the expression of one person. So you can downweight or increase their value based on their social significance in that group. Based on that, a trivial model of group expression, let's call it group expression model, GEM, could be simply, summating the expression intensity, which is weighted by theta I and D of I, and then you have the total number of subjects n in that group. Of course, this is the simplest representation which you could have. You can have more factors added into it by, for example, let's say using machine learning techniques such as latent Dirichlet allocation, right, LDAs. So you can model the relationship between the faces, the group members, wherein the word would be the face, similar representation. One could also use a bag of words based framework, as we discussed in the last lecture, for the dynamic facial expressions. Now, these were techniques where we were using these handcrafted features. You could also use a deep learning based technique for group emotion, right? Here is an example. So here you have an input image, and again what you want is top down features to be taken care of and your bottom up features, right? So these are the ones which we understood from surveys. So this pipeline takes the whole image as an input into a network. So in this case, this is the Inception V3 network, and this is actually taking care of the top down, right? So you're looking at the whole scene. Further, what you do is you detect the location of the faces, and for each face, now you are using a network. In this case, this is a capsule network. You can use a convolution neural network as well. Now this is your bottom up analysis. You are looking at the facial information here, okay? To add more context, for example, where people are, right? You will see, for example, people could be wearing birthday hats only in a birthday social scenario, but not in offices, right? So you can have these facial attributes computed for each face, and all this can be fused together. And this will be the prediction, right? So you can do a prediction here, maybe let's say 3-class prediction, which simply tells you if the perceived emotion is positive, neutral, or negative. And this is just a rough step on your valence axis, okay? Now I'll play a video, and this is an example of looking at the faces and the whole of the scene as well. Now in this case, you will notice that the facial expressions, the body gestures, tell that the overall group emotion is not so positive, right? And here you have, hang on, let's go back to the video, let's play it again. And here on the top right, you have the overall emotion, which is negative, and the bars are indicating the strength. So higher score would mean that people are looking more negative, as you can clearly tell from the expression of the group of people here. Now in this very example, if I was to move on a bit, you will notice that there are a positive sample coming in as well. Let's just wait for it to come. Now obviously one could say that, for example, in this group, one can look at not just the expression but the body gesture as well, friends. The body gesture of the group of people can tell you, for example, they are having a positive emotion right now. So these are very powerful cues which we can extract and later embed into a large number of systems. Now I will share some future directions. So group level emotion is actually a fairly new area. As we are getting more and more data sets collected, for example, here is one from Sharma and others, and then there are other repositories such as there is a happy data set, and then there is a group affect data set, GAF. So these are available publicly. You can download them, train systems and test out group emotions. Now we discussed about image level group emotions, but of course we have discussed when you have time series information, that is giving you a lot more information for understanding the emotion of a person or a group of people. So in this case as well, if you have a video of a group of people, you can analyze the rich dynamics with respect to the group and then add that information to the expression. The other direction, friends, is audio video fusion. So generally in group settings you will have audio information available as well. Now this audio information would be in the form of either the voices, so someone could be speaking in a group of people, or it could be some background music. So that information can actually help us in more robust facial expression recognition, right? So that it will be complementary information. The third is more larger data sets are required. Typically what happens is when you are collecting a data set where you have a group of people and you are trying to label the perceived emotion of those people, there is a lot of variability which can come. Now this variability would be in the form of the labels which different labelers could be giving to the same video. So person 1 could perceive a video having, let's say, very high positive perceived emotion. Person 2 could have it as a medium positive perceived emotion, right? Then how do you get the consensus, right? How do you get the consensus among the labelers? That's important. The other is, how do you decide that one labeler is more consistent as compared to other labeler, right? So if you know labeler 1 is more consistent in creating the data set, is having more consistent labels, then you could perhaps give more weightage to a labeler who is more consistent. And the third is, when you are collecting these data sets, what about the copyright, right? You just can't download videos and use it without proper copyright check. So typically in the academic research community, we will look for data with Creative Commons license. So you can dwell deeper into it and then make sure that the large data set which you are collecting, you actually have the right for it. So friends, this brings us to the end of the group emotion part of the automatic facial expression recognition lecture.